Welcome to FMA 0146 Basic Mathematics. In this video, we are going to discuss Chapter 1.2 Indices, Surds and Logarithm. In this topic, we are only going to discuss some of the algebraic operation and the properties or the rules for these indices, surds and logarithm. First of all, we look at the indices. P power of n. Any expression written as P power n is defined as the variable p raised to the power of the number n, where the p we call it as a base and the n we call it as an index or power or exponent. There are few types of uh, ki- there are few types of n. The first one, if your n is a positive whole number, so means that your p are repeated for n times. So for example, if you have a 5 power of 3, so means that your p 5 are repeated for 3 times and the connector are multiplied. While if your n is a negative whole number, actually is this one is originate from 1 over p power of n. So that when p over power of n are same thing like your p are repeated for, your 5 is repeated for 5 times, but because it happens at the denominator, so the power when you bring out into the numerator, the power 3 will become a negative 3. What happens if your n is a 0? If your n is a 0, any base except 0, okay, we don't have anything 0 power of 0, so we cannot say 0 power of 0 equals to 1, okay, because 0 is 0, okay. So any other number except 0, power to the power of 0 is equals to 1, inclusive positive and negative integer. For example, 5 power of 0 equals to 1, negative 5 power of 0 also equals to 1. Okay, and then over here, every time when we involving the power, please be careful with the minus. Okay, if the minus are located outside of our bracket, so means that the negative term deserve the power. Okay, and then the last one, if your n is a fraction, doesn't matter it's a positive fraction, a positive or negative fraction, as long it is a fraction. So if you p have a 1 power of n, so means that actually is a root of n. So the most typical we know is power of 1 over 2. That is our square root. If you have a 5 power of 1 over 3, actually is our cube root. So now let us look at some of the rules of our indices. If we have two number, okay, two index, they have the same base, but they have the different power. So we can simplify them by using the operator plus. So am times an is become a power of m plus n. If this is a divide, so it will become a minus. If your am with a bracket power of n, actually you just multiply these two. A multiply n. So it means that your an is repeated for n times. Okay, and then what happened just now, like our fraction, but this one, the fraction numerator and denominator are the different, is the numerator is normal power, normal one. So is if it is an n, so you just can separate it is as, if you want to treat it as an n multiplied 1 over n, so you have the root at outside, or you can find the root first, then you multiply. Okay, if you have a bracket, the inside the base is AB, so this n, the power are for both of them. They are the same for the A divide B, so the n are for both of them. And then the last one, to help you to solve some of the problems, especially during later on for the chapter 2, the equation for the index, that is the index property of equality. So for any positive real number a, and then your a cannot be 0 and your a cannot be 1, if ax equals to ay, then your x must be y. And please remember, don't try to cancel these two a. Actually, what we knowing that is when their base are same, and then we say is equal to your ay, so means that x is equals to y. So now we look at example 1. We try to simplify the x power of 3, multiply x power 2 over 3 and divide by x. So all the base are the same. So we just use our first property. If multiply is a plus and divide is a minus, so this is x3 multiply x2 over 3, so it's an x3 plus 2 over 3, and this is minus 1, so is divide x, so is minus 1. So you use your calculator and sum for this one, so you have a x2 over 3. So if you have a larger, so especially you have a denominator with a fraction, so we just do it at the same thing. If we have a 49, we change it to base 7. 7 power of 2 is 49. And then we use the properties of the number 5. These two are belongs to each of the variable. So 7 power of 2 deserve a 2. X power 3 deserve a 2. Y negative 2 deserve a 2. And then the last one is Z negative 3 over 2. Why is a negative? Because we break our divide into a upper part, so it's negative 3 over 2 power of 2. And then this one we can simplify, becomes z negative 3. Negative 2 multiplied 2 is negative 4. Power of 3 multiplied 2 is 6. 2 multiplied 2 is 4. Okay, if the question didn't like this one, just ask you to simplify, you can leave your answer in this way. If some of the question they ask you for the positive index, so these two are with the negative index, bring it down to the denominator will become y power of 4 and z power of 3. And then we look at the question number 2. The way to do it are the same. The only thing now, we have a two different expression here. Okay, a multiplied b. So what we do is we just patiently expand each of them. The first one, 3 times 2 is 6. 2 times 2 is 4. And then we just put a multiply here. Negative 1 multiplied negative 1 over 3, you will get 1 over 3. P2 multiplied negative 1 over 3 is negative 2 over 3. And then the base are the same, they are playing together. This, the indicator is a plus, so, is a multiply, so we have a plus. P6, 6 plus negative 2 over 3, so it's a 6 minus 2 over 3. 4 plus 1 over 3, then you sum up simplify the fraction, then you have this answer. And then the number 2 over here, the first one, there is no other thing we can do, we just keep it here. And then the second part, 3 times 3 is 9. 2 over 3 times 3 actually is 2. And then this one, we bring this up, we become negative 3. And then 3 and 3 x and x play together. 3 plus 9 is 12. And y negative 2 plus 2 actually is y0. And then the z don't have anyone to play together with, so it remains as the same, z negative 3. So if you want to make everything is a positive index, so this one I bring it down as the denominator become a positive 3. And then why I never put y0? Because y0 actually is equals to 1. And then let us look at the question 3. Calculate without using calculator. Actually, this one is more or less just let you to practice how to simplify anything, a numbers, especially a numbers without using calculator. Okay, so there are two different ways shown here. The first one is I try to simplify. Simplify here is 2. 2 times 8 actually is 16. 16, 1 over 2 actually is 4. So if I want to put it in the simplest index is 2 power of 2. Or the other way that is, I change everyone into the same base as 2. So 2 power of 2 times 2 power of 3. 8 is 2 power of 3. And then 2. Then I use the property number 1 and 2. 2 mark plus 3 minus 1. So 2 plus 3 minus 1 is 4. And then I have a 1 over 2 here. Cancel off. So I have a 2 power of 2. The answer will be the same. So It doesn't matter you want to use the method one or you want to use the style one or the style two, the answer will be the same. So let us look at the second one. 9 times 27 over 3. I just simply use the style 2. So 9 I change to 3 power of 2. 27 I change it to power of 3. And then this one is power of 1. I bring it up, become minus. So 2 plus 3 is 5 minus 1 is 4. So 4 multiplied 1 over 4. Okay, 4 multiplied 1 over 4 actually equals to 1. So I have a 3 power of 1. Okay, let us look at the number 3 here. Each of the following true or false. 16 power of 1 over 2 is a false because we know 16 1 over 2 actually is 4. And then the second one, 16 1 over 4. Okay, if you are not familiar with this, we can change it. 16 actually is 2 power of 4. Power of 1 over 4. These two can cancel 2 power of 1. So that's why this one is true. 81 1 over 3. Okay, it's 9. We know that is 81. Power of 1 over 2 is 9. So this one is false. And then the last one over here is 100 negative power negative 1 over 2. So what we know is 100 is 10 power of 2. Power of negative 1 over 2. And then we bring our 10 power of 2 up. So I have a 10 minus 2 multiplied with negative 1 over 2. So cancel, negative, negative is positive. So we have a 10. So this one is a true. And then we have example number 4. Simplify the following. Okay, so this one quite simple. Just let you to practice. 3, 3. So x power of 3. So how about this one? So you no need to think much. Just bring this one up. We have a negative 5. Okay, how about this one? So you just use the properties of number 2 is bring the power up. So you will have a 1 minus half is a half. So happen to your D are the same. Half minus 1 is a power of negative half. And then how look at example 5. Rewrite the following expression using only positive indices. So means that you cannot leave your answer in a negative form. Okay, so if we look at here, 2 and 2 play together. A alone, B and B play together. So 2 and negative 3. So I bring up because it's divide. Divide, so it become a minus 3. And then A is alone. So we copy back. And B is negative 2. This one is divide. So it's become minus 4 is become plus 4. So we sum everything. We become 2 power of 4, b power of 2. Why the 2 is underground? Because it said that it must be using positive indices. Okay, so how about we look at the question B? Okay, if the question didn't say leave it in positive indices, actually this one is sufficient. But because the question said must be leave in positive indices, so I change x negative 1 to become 1 over x, y become 1 over y, and then the denominator as the same x plus y. So we equate the denominator for the top. I have y plus x divided by xy and use the remark over here. So I bring my xy down and these two are same. So I have 1 over xy. And then the last question of this one is, we see that seems like no way to simplify, but remember 10 and 4 still can be reduced. So I 10 is 2 times 5 and the 4 is 2 times 2. And use the property of number 6. We dispute the n. Okay, so I have 2n, 5n, 2n, 2n. So 2n are the same terms for the both part. So I factor out 2n. So I have 5n minus 2n. These two are similar. So I have a 2 power of n. So now we have a little bit time. Please be careful of this one. When you want to simplify the fraction, especially for the 3 layers type, please be careful. Please be notice which one is the original of the fraction. Okay, thank you.